Okay. Hi, my name is Brenda Cook. I'm an Android developer. I've been doing Android development for about 5 years now. And today I'm going to talk to you about Fragments. It's kind of an introductory type talk. So I'm not going to get really too deep in the inner workings of Fragments because there's so much to cover. I couldn't possibly cover it all, but we are going to talk about quite a bit today. So the talk is kind of 3 parts. Why were Fragments added to the Android framework? Provides a general overview of how they work and gives some examples of what they can be used for. The artwork right here was done by my daughter. She wanted to give me something that I could hand out at a conference that I spoke at earlier in Texas. And she was like, "Here, Mom, you can hand these out to people." And so I thought that it was great. So I included it in my slide here. So who needs Fragments? The answer is you. Fragments are instrumental for creating really beautiful and dynamic user interfaces. There's people out there that advocate against Fragments. It's kind of there's a bit of contention when it comes to Fragments, and I can definitely understand both sides. There's a lot of good points as to why Fragments aren't always the easiest to work with, and that there are other solutions out there. I'm not here to tell you whether Fragments are good or bad. I'm just wanting to give you the facts. Whether or not you are going to go out and use Fragments and say, yeah, Fragments are great. As an Android developer, you need to know how they work and how to work with them, because you are going to go somewhere and work on a project with other people or at a company, and chances are highly likely that there's going to be Fragments and you're going to need to be able to work with them.
Excuse me, can you use mic? Yeah, it's just for the recording. So, okay.
So why Fragments? Why were they added to the Android framework? So Fragments, like activities, act as controllers. Fragments are self-contained components that resemble activities. You can think of them as like mini activities. Unfortunately, activities inherently couple their data access logic with their views, and as such, so do Fragments. It's really the developer's responsibility to layer your data, to separate your business logic from your views as much as possible. As your app grows, you'll be really glad that you did. So if Fragments weren't created as a way to provide a separation of concern, then why? And the reason actually is because as Android started becoming more popular, there was many manufacturers that wanted to create devices, and that ended up with a lot of device fragmentation. And so this became a problem because it was difficult for developers to be able to write apps that were suitable for all of the different screen sizes and densities out there. So the solution was to offer scalable, swappable user interface logic components that can be transitioned to and from as needed based on things like UI flow, screen size, orientation, and density. So the goal of Fragments was to facilitate the decomposition of application code into reusable chunks to make application development more flexible. So in order to understand how Fragments work, you need to understand the life cycle, and you need to get really versed in it. Unfortunately, we all know that Android, activities have a very complex life cycle, and fragments are the same. In fact, they're actually worse. There's more callbacks to know when it comes to fragments. So this diagram I'm showing you here is actually, yes, I know, it's a lot to take in. It's actually the activity life cycle compared to the fragment life cycle. On the right, I know you can't really see any of this. Don't worry about that. I just want to show you the whole scope of this. On the right is the activity life cycle. On the left is the fragment life cycle. And you can see that even though there's a lot going on with the activity life cycle, which I'm sure you're all painfully aware of, there's even more going on the left side here. So this diagram is a little bit easier to digest. Many of the callbacks were removed, and that allows us to focus on just some of the important few. This diagram left out a couple of callbacks that I felt were worth mentioning, so I went ahead and sort of stuck them in there. So the two I added in there was on view created and on view state restored. So I'm just going to go through a couple of these, some of the creation callbacks. The first one shown here is on attach, and depending on whether or not you added your fragment statically or dynamically, on attach will be the first callback you'll receive if it was dynamically added. Otherwise, the first one is actually on inflate if you statically added your fragment. Once this callback is received, you're no longer able to call set arguments. So don't try to do that. You need to do that beforehand. OnCreate comes up next, which you are undoubtedly familiar with. You need to be careful here because a lot of times in your activities you'll probably put a lot of your setup code and your initialization stuff in OnCreate. You want to be a little bit more careful about the initialization and setup that you put in the fragments OnCreate, because you don't want to put any code here that will rely on the parent activity's view hierarchy, because you don't know for sure that it exists yet. So there's chances are good that it may not. So you want to wait until you're sure that the parent activity has been created by, and which you would know through the on activity created callback. On create view just comes immediately, on create view is where you want to return a view hierarchy that'll be displayed for this fragment if this fragment has a view. I want to note that you don't want to attach this parent or this view to the parent view group yet, so you want to pass false in that last argument, which I'll show you later on. And this will occur for you automatically at a later time. On view created is called right after on create view, but before any save state has been put back. So if your fragment was recreated from save state, any code. If your fragment was recreated from save state, then it won't be put back in here yet when you've received this callback. And then so on activity created, which I'm sure you're probably familiar with, and that's the one you get once your activity has been created and its on create has been returned. And then I added on view state restored, which was introduced in Jelly Bean 4.2, and it's invoked once the view state has been restored from saved state. So prior to that, you had to make decisions on whether or not you wanted to tweak your view or tweak the user interface in response to the view being restored from save state. and you needed to do that kind of probably an onActivity created and kind of just sort of make assumptions on whether or not it was restored. And with this callback, you can know with confidence that your fragment was restored from save state. So static versus dynamic. There are two ways to add a fragment to an activity. You can add it declaratively in your XML, or you can add fragments dynamically at runtime in your Java code. The latter is typically the way you want to go. If you add a fragment statically in your XML, you can't ever remove it. Your app will crash if you try, so that means you can't replace it either, because that replaces just the equivalent of remove and then add. So here's an example of adding a fragment statically. I've got the fragment tag here where you need to assign it an ID, or you can use the tag attribute to reference it, and then apply the name attribute specifying which fragment class to use. So here I've got Android ID, which is puppy list, and then the name is puppy list fragment. So if you're going to add fragments dynamically, you need to know a few very important rules. The first rule is that you must always have an empty public default constructor as shown. This is so that Fragment Manager can recreate fragments when recreating its parent activity, for example, if a screen orientation should occur. The second rule is to avoid using an overloaded constructor, which is just a constructor that has parameters. Instead of using an overloaded constructor, you should use a static factory method to create new instances and then apply your initialization arguments. The static factory design pattern is a handy one, and it just simply abstracts the creation steps required when creating a new instance. And so once we've created a new instance of our fragment subclass, we need to create a bundle, and then we can set that bundle by calling set arguments. You want to avoid doing any other work other than just creating the instance and then setting the bundle arguments in your static factory or in your static factory method. So by setting your arguments using a bundle, your fragment state can properly be restored if needed, because your initialization arguments will be reattached if it's recreated, and these arguments will be accessible to you via get arguments. So you might be asking, why do all this? Why can't I just use a parameterized constructor and be on my way? And that's because, like I said, Fragment Manager sometimes creates fragments. You're not always the one who's creating the fragment. So if the fragment gets destroyed, say a configuration change, then Fragment Manager needs to be able to recreate that fragment for you. And it uses this, this default constructor. If you have any other constructors, they're just going to be ignored, and you're going to lose all of your initialization data. So taking a closer look here, the steps to dynamically add a fragment include creating a new instance of your fragment subclass, as you can see in the bold here. And then we're using, so new instance is just a convention. You could actually call it whatever you want. And then once we've done that, the next step is to get a reference to our Fragment Manager or support Fragment Manager if using the support library. So that's that right there. And then here we can call add or replace or whatever it is that we're trying to do, and then a call to commit. So as I mentioned earlier, replacing a fragment is very similar to adding a fragment, except that when we replace a fragment, the replace method or the remove is called before add. So this is an example of the master detail flow, and you can see this, all of the code on my GitHub repo, which I will post a link at the end of this. So this is just a list fragment, which is added to the master activity. And then when an item gets selected, a new activity is brought forth, and that is the detail fragment. Or it's filled with the detail fragment. So let's see that shit. There we go. So destruction is like the activities destruction process. It's just, of course, got a few caveats. On save instance state. This is not guaranteed when it's going to happen. It can happen anytime after on pause and before on destroy. So you can see I've created a little bracket to show you the area where on save instance state might be returned to you. Usually it's going to happen before on stop, but again, it's not guaranteed, so don't make assumptions on that. There's no on restore instance state like in the activity lifecycle. Instead, the bundle object is passed to on inflate, on create view, on view created, on activity created, and on view state restored. Like activity, the bundle passed to these methods will be null unless it's restored from save state. So it's actually a way to circumvent some of this lifecycle process when the parent activity is destroyed and recreated. As long as the fragment is not on the backstack, you can invoke a set retain instance and then pass true in your either onCreate or onCreate view callback. If set retain instance is set when the fragment's activity is destroyed, the fragment itself will not be destroyed, and on destroy callback won't be invoked. Because on destroy isn't invoked, on create won't either. You won't get that one. The good part about this is that the fragment is still detached from the activity, and then on attach will get called. So that way the fragment is attached to the new activity. So like in a configuration change, it'll be detached from the old activity that's going away and attached to the new one that's been created. This is also a powerful feature to use with what's called a headless fragment, which is a fragment that doesn't have UI. It's a nice way to be able to hold references to objects that you can't allow to be destroyed in circumstances such as an orientation change. So let's take a look at some more examples here. What you saw earlier was the master detail flow for phone size screens. Here's what that looks like on a tablet. So we can specify different layouts based on screen properties such as the size, density, etc. So this is a very simple layout that's going to hold a list fragment. In this master detail example for phone size screens, the navigation list fragment only contains a fragment tag, and which is defining our static list fragment as well as setting the container's layout parameters. Often the detail container will be a frame layout, however, that's not always the case. In this example, the detail container is actually a nested scroll view in conjunction with the coordinator layout. And I'll actually touch on that on the coordinator layout a bit later. And I also use the collapsing toolbar layout to achieve the little animation effect that you saw in the phone size demo. So here's that animation again, in case you forgot. Another opportunity to look at cute puppies. So in the tablet layout, I've defined a horizontal linear layout and included a static fragment for our list, along with a frame layout to serve as our detail container. These are going to display side by side on the screen. The tablet layout will not feature the animation since we don't have the collapsing layout. I'm just using a frame layout, nothing more. So how does Android know which layout should be displayed? So at runtime, Android detects the current device fragment or the current device configuration and selects the available resources based on qualifier matches. Various qualifiers can be defined for a resource, including screen size, API version, language width, height, screen orientation. There's a lot of different qualifiers that you can choose. Here I've defined the smallest screen width, which is indicated by the SW in the parentheses there. And a density of 600 density independent pixels, which means that the smallest available width that is required for this layout is 600 dp. And if it does not meet at least 600 dp, then this layout won't be used, unless it's the only layout you've got for some reason, which there should always be some sort of default layout. So to create layouts that adhere to resource qualifications, you just right-click on the layout resource directory and then choose New and then Layout Resource File. So a wizard will come up that will allow you to choose from many different qualifiers. Here I've selected the screen width and then entered in 600. It will auto-populate the file name for you. So you don't need, or I'm sorry, the directory name, so you don't need to even enter anything in there. So even though Android takes care of selecting the appropriate resources for us, we still need to determine if we are displaying one fragment or two fragments at a time. So in our activities on create method, we should determine if it's two pane or single pane layout. If it's two pane, we will know because our detail container will be null. Whereas if it's single pane, I'm sorry, it'll be null. If it's two pane, then there will be something in it. If there's any code specific to the two pane, then we can just go ahead and execute that. So another common navigation design pattern that involves fragments is the tabbed ViewPager. Here's what that looks like. So in order to achieve this material design tab style navigation, we need to create a layout with the coordinator layout as the root. The coordinator layout was introduced fairly recently with the design support library. I'm using it here as well as a single pane layout that we looked at earlier and the navigation drawer example that we'll talk about next. Coordinator layout is described as like a super-powered frame layout. It just allows us to specify behaviors for child views, allowing us to coordinate them so that they can interact with each other. So nested inside the coordinator layout, we have here, oops. We have a ViewPager that is serving as our Fragments detail container and an app bar layout. The app bar layout contains two child views, a toolbar widget and a tab layout widget that will be for our tabs. I've set the tab mode to scrollable so that way we can horizontally scroll the tabs to access any tabs that may not be on the screen if there are more tabs than just what can be displayed immediately. So in order to use the ViewPager, we need to create an adapter that extends Fragment Pager adapter and passes in a Fragment manager and invokes its superclass. The implementation, again, is not shown here, but you can access the Puppy's ViewPager sample code in my GitHub repo. In our main activity, we'll need to create a new instance of our fragment and then add the fragments to the ViewPager adapter. So we can leverage our fragments on create callback to get initialization arguments that we set on the fragment at instantiation by calling getArguments, and then set any variables accordingly. It would also work to do this in onViewCreated or onActivityCreated, depending on whatever you're doing. So don't confuse getArguments with saved instance state. GetArguments are the instantiation arguments that you set when you created your fragment instance, and they are not the save state, which can be found in the save state bundle. So now when the onCreateView callback is invoked, we have our data ready to load. If you choose to delay getting your initialization data, you'll need to set your views later as well for obvious reasons. First, we must inflate our fragments layout by passing the ID of the layout we wish to inflate in our parent view group container. The last parameter, like I mentioned earlier, is used to attach the view to the parent root. So we want to pass false here. So we can use the page number field set by the initialization arguments to get the right image ID needed for our image view, as shown in the bolded code here. Once all the views are set, we can return this view. So material design specs suggest that developers should favor a tabbed navigation when possible. However, if you have a lot of menu items or maybe submenus, you may not want to use the you may want to use the navigation drawer instead. So here's an example of material design navigation drawer, and I'm not going to go into a lot of detail on the implementation on this. So this navigation drawer example consists of one activity and one fragment class. When a menu item gets selected, the detail container is updated by getting a fragment transaction and then calling replace on that transaction and committing it. So again, here's what that code would look like. Maybe you want to be able to allow the user to navigate back to their previous screen. We can achieve this by calling add to backstack before committing the transaction. By calling add to backstack before committing the transaction, we're telling Fragment Manager, remember this transaction. We can optionally provide a name that represents this transaction state, which I have done. I just called it details in this example. When the user navigates back, the transaction is popped off the top of the stack, and whatever you did in the last transaction, the reverse would happen. Conversely, to pop the last transaction from the top of the stack, we can call pop backstack or any of its variations. This is comparable to activities on backpressed. So DialogFragment. Dialogs are windows that just float on top of the current window. They're typically used to display information that, that the user must interact with or acknowledge. The benefit of using dialog fragments over a dialogue or an alert dialogue that's not contained within a fragment is that we can be assured that our dialogues will obey the fragment's lifecycle state. This removes the need for us to manage the lifecycle ourselves. So it's very helpful in case of things like the user backgrounds it, and it'll just do the stuff. We don't have to worry about it. So DialogFragment is a subclass of Fragment, and as such, you can expect it to have similar behavior. There's two ways to construct a dialog fragment. And the first way is to override onCreateView, like a typical fragment. Overriding onCreateView is easy to implement. It's probably going to serve you better if you have a complex dialog rather than overriding onCreateDialog. This method also has the benefit of providing the possibility of being able to use the dialog fragment as an embedded fragment or as a floating dialog window. The second option is to override onCreateDialog, which uses the alert dialog builder, and it's a good choice for simple dialogues. It's what I would typically use unless I needed to do something fancy. We're actually going to take a closer look at this method. So right here, this class extends the dialog fragment and implements dialog interface on click listener. Again, for the slides here, I didn't get all the code on there, so I removed most of it. But you can see that in onCreateDialog, I'm inflating a view to be set when the dialog is built. And this is actually optional, and is something you don't need to do if you don't require any custom views. The next step is to create an alert dialog builder, set the desired attributes, and then return the resulting dialog by calling create. And then once your dialog has been created, whether you've overridden onCreateDialog or onCreateView, you're now ready to show the dialog, and all you need to do is invoke show. Show requires that you provide a fragment manager or a fragment transaction and a string tag. Just like standard fragments, the transaction manager is used to add the dialog fragment to the activity and commit the transaction. Show does not add the transaction to the backstack. You must do this yourself. If you want to add this to the backstack, then you're going to need to do this before calling show by passing by using the method that takes a fragment transaction rather than the fragment manager. So here's what our dialog might look like without setting a custom view and a custom title like I did in the sample project. And then here's what the dialog fragment looks like in the sample project. Dismissing a dialog fragment. So the most common way to dismiss a dialog is to explicitly call dismiss in response to an event. They clicked a button. When a dialog fragment is dismissed, the fragment is removed and the operation is committed by the fragment manager. If the fragment is, or if the transaction is on the backstack, then the transaction is popped from it. DialogFragment follows all of the regular destruction callbacks, including onDestroy. In addition, though, it will receive onDismiss or onCancel if the dialog fragment is canceled due to an event such as the user pressing the back button. You should not assume that onDismiss is a reliable indicator that dismiss was called by your code in response to the user interacting with the dialog fragment. If the example configuration should change, then onDismiss gets called, and you may not want to execute the same code in that use case. So obtaining information from the parent activity is simpler than the other way around. There are many ways to achieve this, and people have a lot of opinions over the best way to do this. But I'm just going to show you a super simple and common pattern using a simple interface. Android Studio even adds this as an option when creating a new activity that uses a fragment via the wizard, the new wizard. So here I've just defined an interface. In the sample project, I've defined this interface in the fragment itself. In your fragment, check that the parent activity is implementing the interface. And then add your interface method implementation to your activity. In my implementation here, I'm showing a toast that says thank you if which salutation is equal to goodbye. And then finally, add your logic to your click listener. Here I'm going to call my onDialogDismissed method to show my toast message if the required condition is met. Thank you.